Hello, this is the fourth video in a series of 5 videos that I've planned to talk about complex numbers. And in this video, we're going to simplify a problem that looks a little more complex than the one that we simplified in the third video. We did two in the third video. We have some keys that we want to keep in mind, and that is, first of all, I is the square root, defined to be the square root of minus 1, and if you can factor the value under the radical sign, then the square root of a times b, that number, is equal to the square root of a times the square root of b, and this goes both ways. If you have these two, you can put it back into under the sign, and we saw that last time. We ended up with a square root of 3 times the square root of 6, which equals 18, and 18 is also factorable by 2 and 9. So you want to keep your mathematical mind open for looking for perfect squares. All right, without further ado, this is the problem we're going to solve. And before you go and stick pins in your eyes, let's just look at it. 2 times the square root of minus 4 times the square root of 2 plus 3i times the square root of 2 minus the square root of minus 4 times the square root of 2. Now, the first thing I'm going to do here is I'm going to look at this term and this term. These terms have the same radicals in them. Here's one of them. This one has a 2. There's 2 of them. And you're going to be subtracting off one of them. So the first thing that we can do to make this a little more digestible is to subtract 2 from 1. It leaves you with 1. And so we'll have the square root of minus 4 times the square root of 2 plus 3i times the square root of 2. Okay, so already it looks a lot more doable. The square root of minus 4, we break into the factors. 4 times minus 1. Square root of 2, we don't need to do anything with it. It exists, it's a real number, plus 3i square roots of 2. Notice how math books do this sometimes. You can see an I in there, but then they give you this I. So you don't have to worry about it. And so we bring this out, the square root of 4 times I times the square root of 2 plus 3i square roots of 2. Now, the square root of 4, it's a perfect square, so we have now 2i times the square root of 2 plus 3i times the square root of 2 equals nothing less than 5i times the square root of 2. And so you have all of this going on, and it simplifies to this lovely expression that we can all digest. Remember, we got here because we're adding, we're not multiplying. And so we have a number, an I, and a square root of 2. So we're not adding apples and oranges or anything. We're just adding how many square roots of 2's do we have? Well, we have 2i of them here and 3i of them here, so we ended up with 5i square roots of 2.